Good morning, everybody. Welcome to week 6. Good morning, Rob. We are going to start a little series here. It's going to take a few weeks to get through. We've been dealing with architectural and interior construction. We've gone through elevations, we've gone through scale, and we've kind of not gotten into the whole engineering and civil part of this yet. It's really the beginning of a project. It's the first thing you work on, and I thought it was important to take you through the survey, the grading, the water management, and the whole process that gets you from the ground to the house. Okay, so we're going to start very basics as far as grading goes. First thing on a project would be the survey. So everybody should have two 11 by 17s in front of them. One is the civil plan and one is the survey. This is a boundary survey. It's also a topography, or what we call a topo. Okay? When you start a project, a surveyor comes out and he basically surveys the entire plan and does a drawing to scale that everybody works off of. The topo part of it is actually pinpointing certain grades on the property and on the adjacent property, as well as elements that exist, such as trees, site walls, fences, things like that. All these are going to aid him in determining what has to be done going forward. Okay? Certain things, for example, when you get to the east side of the street, certain surveys are required to move forward with DEP. For example, if you're going to file a DEP permit for anything on the east side of the CCL, and I'll explain that in a second, you need a survey no older than 6 months old. So if this, mainly to establish the mean high water line, but if you had this and it was a year old and you went to the DEP, they would not accept it. Okay, so let's go through some very basic elements on here. If everybody sees what I have highlighted on your plan, that says coastal construction line. We call that predominantly the CCL. Okay, you'll probably hear the term CCL more than you hear coastal construction line. Everything to the east of that is highly regulated. That's from the sand that you bring in, permits that you get, in our favorite, the turtle people and what they look at. You have to be very conscious of where that line is, okay, because you're going to have to deal with it differently than you deal with other parts of the construction, and we'll go into that more later. This is going to be a long process getting through this, so I don't want to harp on any one part right now. We will get to all these parts as we go on, but right now I just want to give you the layout. Okay, if you look at this plan, it does show a fence along the north side of the property. It shows a site wall on the left, on the bottom, and you will see certain terms on here so you know what they mean. For example, TOW is top of wall. So if you look at the bottom of the page, you'll see an existing wall that separates the two properties. All the points you see here with numbers, these are all elevations, okay? So the surveyor goes out and periodically in a grid, he measures all the elevations. Now, why do we need this? When they develop the plan for this, there's a few things I have to take into consideration. One is obviously how it works with the building, right? How the building, the entrance, the exit, the grades, things like that. But the most important thing is the water management. Okay, is the house going to flood? You're supposed to be able to maintain all the water on the site within the site. It's not supposed to run off to your neighbor's house. It's not supposed to run off to the ocean. It's supposed to be maintained within the site. So there are different things that are done to maintain that. And when we get into the second drawing, which is the civil plan, we'll go into some of them, okay? What you will find when you look at this is that the neighbor's grades are as important as the grades here. Because if the neighbor's grades are at one height and I cut down to build my house and do my drainage to a lower height, now I have to account for that difference in height. Okay, and we'll get into that when we go to the civil. So let me explain so everybody understands grades. Okay, everybody have this? This is basically a very simple plan to understand, but if you've never been exposed to it, it's not that easy. Okay, if you look at this plan and this plan, okay, this is a civil plan, you'll see grade lines. Okay, you see lines going along them with numbers on them. Does everybody see that? Everybody see that? What that is basically showing what this is, okay? If you had a stack of books and each one was a different grade and you leveled that out, you would have a hill. That's basically what this is, okay? So if you look at the driveway starts at elevation 21. Does everybody see that? Okay? Then as you go down the driveway, it's 20, 19, 18, 17, etc. What this is showing you is along that line, that's the grade. Everything within that line is level at that line until it breaks. So what this is showing you is that the grade going down the hill is dropping till you get to the garage. Everybody see that? Okay. Now the grades, if you see the line that extends all the way to the wall, what that means is that that elevation is level all the way to the wall. The next elevation is level, and it goes down gradual. If you see the line that says 15, about halfway down the driveway, you'll see it goes to the corner of the wall and it splits. Right? Does everybody see that? So what that means is between those two areas that split, it's level. Okay? It pitches one way, the other way, but at that point, it's level. This is needed for many reasons. Okay? First of all, the civil engineer is looking at water management, which way water is going to flow. And when he does his drainage system, he's looking at, am I directing the water to the drains? Okay? Or am I letting it run free and it's going to fall into the neighbor's property or the street? This is the prime reason we do grading. This is the prime reason the civil engineer is so deeply involved in this project early. Okay? So does everybody kind of understand how stepping works on grades? Okay. If you look at this plan, this is a civil engineering plan. Okay, this is going to show you on one sheet the footprint of how this house is going to lay, how the drainage system is going to work, and how each of these grades fit with the house. Now, when we looked at this, we found some problems, okay? And I'll explain that to you. And this is why it's important. In the past, I've said it's easier to correct something on paper than in build, okay? So when you first get a set of plans, your review of these plans is very, very important. Because at this point, you can get in touch with the engineer. You can say, how does this work? This doesn't look right. Or you can wait and it'll hit you in the face. Okay? So for example, if you look on the right along the street, there's a line that says TOW 25.5. Everybody see that? Got that? What that means is at that point, the top of the wall is 25.5. That's the elevation. Okay? Now, that doesn't seem to be a problem where the grade is 19. At that point, I'm 6.5 feet up, right? But look as you go down the driveway where the grade is 15. Now that wall's 10.5 feet high. Okay? You catch that now, you're not allowed to have a 10.5 foot high wall. So you bring that up. That brings a bunch of issues to head, okay? One is if I alter the grade to keep a shorter wall, now you got to look at the impact of how it affects the driveway, how it affects the grade, how it affects the drainage, okay? So you look at these and you find things like that. On the south side or on the bottom of the plan, you'll see a site wall. And it says top of wall 20. Right here. Everybody see that? Okay. Now that top of wall is 20. If you look on the other one, top of wall is 25 on the existing wall. That wall becomes irrelevant. You don't need it for that part of it. So you have to go through these plans ahead of time. You have to understand what they mean. You have to basically picture the contours just like this. Okay? You have to picture the contours of how this property is going to lay out so you can see what the intent is. Everything we talk about has something to do with intent. We talked about interior design and what is the intent of what the designer wants. Here, there's a method to how the drainage works. When you do something that affects the grade, you affect the drainage. Okay? All this is already established by the civil engineer, and anything that changes that has to be brought to the civil engineer's attention because he's the one responsible for the drainage. You never want to make a change, you never want to make a change and not run it through or have documentation from the civil engineer, because later on, if there's an issue, he's going to tell you that's not what I designed. Okay? Everybody got that? Okay. There's a few things on every civil plan that we talk about. And like I said, the most important thing here is water management. Okay? You'll see a few things on here that deal with water management. Okay? You'll see these. See these lines right here? Okay? These are exfiltration fields. These are areas where a drainage system is installed for a period of time. If anybody looks at this page, you'll see this diagram. Okay? In its simplest form, this is an exfiltration field. Okay? It's an area that's excavated. It's got filter fabric first so it doesn't have soils go into it and it stays clean. It has a perforated pipe that runs through and usually gravel. Okay? The drawing will say how big it is, how tall it is, how wide it is, how long it is, and what the rock inside is, whether it's number 2, number 5, drainage rock, whatever it is. Okay? These are all specified and designed by the civil engineer for the specific application of this drawing. He's going to calculate how much water has to be displaced by this system, and he's going to design these elements to take that much water without overflowing. In this case, he's actually designed it with an overflow, so anything that does make it through pops up and goes to the south. Oh, excuse me, in this case to the west. Okay? He's got exfiltration fields at the top, in the south, and the north. This is his design. Okay? You'll have tubes, you'll see there's grates. You see the squares and all the piping. There are grates that take the water and feed them through the exfiltration fields. This is common. Okay? This is a common system. You'll see it on almost every plan you have. We usually go overboard. RWB does more as a rule than you have to do. Okay? We usually do a perforated driveway system, where if you can picture this drainage field here, you can picture a drainage field under the entire driveway, where the entire driveway has 18 inches of rock and the water goes through. We do that in addition to everything that the civil engineer does. It retains the water almost like a 100-foot long exfiltration field. Okay? We always do the most. Okay? You will find, if you look here, a similar idea. Okay? This is a drainage system that we put at the base of the wall when you have a retaining wall at the house. For example, if you're at the front of the house, the basement's 12 feet down, you've backfilled, you've waterproofed, you've backfilled to the house. Before you backfill, we do two things. We do a perforated pipe similar to what you just saw in the exfiltration field. We tie it into the drainage system. We also put a drainage mat on the wall, so when the water hits the wall, it carries down. It's almost like an egg crate, okay? The idea of all of this is twofold. One, to keep the water off the house and avoid any pressure to the house at a retaining wall or a front wall. And the second thing is to maintain all the water on the site. Okay? Those two are extremely important, and they're going to be the crux of everything we do here. Okay? The third thing that we're looking at here is a septic system. Okay? We use, in Manalapan and basically all around, we use a microbiotic system, okay? But it's basically a more advanced system of the basic septic. So if you look at this drawing, okay, what a septic system does in its infancy, before we get into putting it on steroids, what a basic system, septic system generally does is it takes waste, goes into a tank, the solids sink to the bottom, and the liquid stays full. Just like if you were dissolving something in water and the bottom, all the stuff collects at the bottom of your glass if it's not mixed right. It's the same thing. Only in a traditional septic system, the water that goes to the top overflows into this pipe, and it goes out into the field. Once it gets into the field, it's dispersed and it sinks into the ground. Okay? There's very strict rules about how a septic field works. The type of sand, how deep it is, how much sand is underneath it. All this is made so it drains properly. Okay? As a rule, you're not supposed to have more than 6 inches on top. There's supposed to be a certain amount in the bottom. Even if you're on the ocean and you have beach sand, that doesn't mean the sand is appropriate for a septic. Okay? In almost every case, they'll grade out the sand that's there and they'll put in clean sand that fits the septic design. Okay? So this is the concept of how a septic works. If you have a property that has a well, this obviously is an issue because you don't want this too close to your well. So there are restrictions as far as how far these can be apart. If you have a well, sometimes it's 100 feet, sometimes it's 75 feet, because you don't want what's coming out of this going down into the water system and then being pumped into your drinking water. So there's a separation. And again, that means that separation has to be not only within your property, but if your neighbor has also. So for example, if your neighbor's well is right next to your property line, even though it's not on your property, it's within X amount of feet of your property line. You want to make sure when you do your plan, and the health department will regulate this, you're so far away from his well, from his septic, you have to consider all the adjacent properties as well as yours. Has everybody kind of got that? Okay. This is what you'll see in Manalapan, okay? This is what we use, and I printed this out. I'm not gonna go too long into it, but you guys can take this and read it. This pretty much puts your septic system on steroids. It's got a blower in it that actually circulates, oxidizes the water, and exaggerates this process. It's almost like putting the septic on steroids. Okay, take your time, take this home, look at it. You've all seen these on site. Okay. They work really well, and people in Manalapan, they prefer them, okay? One of the things that we do as a company is if you see these tanks within this system, it's our practice to run a sewer line from these tanks to the street whenever we do a job. Because in the future, If the town decides we're going to put a sewer line in, at that point, you can take the line that you've run from the tank to the street, and you can make this a pump station instead of a septic system. So you can tie into your sewer by means of changing the guts of this system, okay? While we're building, make sure you run that line, okay? It's a standard pipe, and it runs, usually we run it out along the corner of the property, we extend it past the site wall at least a foot or two, and we know where it is. Okay? To try to run it later would mean ripping up your lawn all the way to the street. To run it during the construction process, it's nothing. Okay? So what this means to us is we have to think ahead. Okay? We had talked last week about building this in your head, the critical path that's in all of construction. When you look at this original survey, you're looking at the grades. You're saying to yourself, what's next? After you get this and you get your civil plan, now you're looking at this. And again, it's easier to fix it on paper than it is to fix it in reality. Okay, you look for things that are an issue, like this 10.5-foot wall. You know, you look for things that are going to be a conflict later. And you try to address them before you go too far. If you don't, they're going to bite you in the butt later. Everybody understand that? So, let's start with this. Anybody have any questions about what we just talked about?
What's the height allowed for the wall in Alabama?
I think the code is 6 foot. Allisontown is very good at going through these things. You also, and I'm going to bring up something I've brought up in the past, okay? All the plans you see here have all gone through civil engineer, structural engineer, town of Manalapan, all the review process, landscape engineer, landscape architect. You're going to see things on here that have been through the review of 12 different people. Okay? You cannot just accept that this is okay the way it is. Okay? I cannot stress enough, when you get a set of plans, don't just assume what's on here is correct. Anybody who's been doing this will tell you there's numerous occasions where you come in and nobody thought of anything. On this plan, for example, if you look at the north wall, the neighbor's property at one point is at 22 feet high. The driveway is at 11, which means the bottom of the footing is at 10. Okay? That means I have a 12-foot cut straight down that I have to make. Nobody thought of it. Okay? You're building it. You have to think of means and methods for everything you do. You have to look at that and say, how am I going to build that? Not just let it go until it comes to bite you in the butt. You see the walls that you don't need. You see grades that don't work. You see a wall that is too tall. You see something that was missed. You have to go through this as if you're giving it its final review before build. Okay? You're the one putting your name on this. You're the one that's going to run this through the process. The guy who went through this before you is looking at it and says, yeah, that works. He's not looking at how you're going to build it. You guys have to look at this like a little inspector. And every one of you has to go through this and say, do these drains work the way they sit? Are these grades going to work? Can I cut this out? When we build this house, we put sheet piles around the house. Everybody know what a sheet pile is? Okay? The reason we do that is when I put this basement in, I have to cut this down 12 feet. If I cut this grade down 12 feet, it's going to be all the way to the street. I'm not going to have enough room to pitch it to the neighbor's properties. So I have to put sheet piles in so we can lower the grade within the sheet piles. Okay? All this has to be thought out. The person drawing this plan is not looking at how it's going to be done. They're looking at what they want in the end. Okay? They want this wall 12 feet down. They're not saying how it's going to happen. They're saying there'll be a wall, they'll give you a plan for a wall. The wall on the plan will work out great, but how do you put it in? They're not looking at that. You have to look at it. You have to look at it early. In everything we do in construction, it's means and methods and critical path. When we talked about the schedule last week, Carl calls the critical path. It's the path you go to get from point A to point B, and you have to anticipate everything that's going to happen within. Everybody got that? Okay, so I've printed you up a few things to take home and look at. I've printed you up some information on grades, walls, the system. We had discussed last week very quickly NAVD and NGVD. Okay, these are standard elevations set by FEMA and the DEP. When you go to get your surveyor in, he will give you an elevation that you will hold as the standard for the job. It will most likely, or it should be, NAVD. This sheet will give you a better handle on exactly what we're talking about. Okay? He is going to give you a reference point. He's going to come in and give you a fixed item like a pole or concrete or something that is not going to move. And he's going to put an elevation mark on it. It doesn't have to be anything specific. It could be 20 feet, it could be 25 feet, 20, 19, it doesn't matter. Because what you're going to do is you're going to take that elevation mark and you're going to measure down or you're going to measure up. Usually when the surveyor comes in and he measures all this, I ask him to give me 2 or 3 points around the property. Because when the guy is going to lay out everything later, which we'll get into when we get the structural, he's going to need a point of reference. If we have multiple points around the property through a laser, he can take that point and transfer it anywhere. Everybody has to be working off the same point. Just like inside we had a benchmark that everybody was working off as far as putting outlets up or down or ceiling heights or cabinets. Outside you have the survey mark. That mark has to be maintained for everything, or you're going to have a problem because the first floor here is going to be different than the first floor here. Okay? Anybody got any questions? Okay. Pretty good for today. Take the paperwork I gave you home. Look at the survey. Look at the topography on the survey. Look at the grading. And look at the information I gave you as far as drainage. What I've given you here is pretty standard for what you're going to see. Okay? And all these things like exfiltration fields will have a page attached to them on the drawing with a clear detail of what the engineer expects. He's not going to give you this and you're going to say, oh, it looks like it's 2 feet. No, there will be a page. Every item here, every catch basin, every catch basin, every exfiltration field, every item, even the septic, everything will have a description in the pages following the civil plan. Okay? Your plumber or whoever's doing your work has to follow these details specifically. There will be an inspection on all this, and it's really important because if these are not low enough, you will get hit later. For example, the exfiltration field that's under the driveway. We have 18 inches of rock under the driveway, okay? You have to make sure those things fall within the clearance you have for the driveway. If they don't, you go back to the civil engineer, okay? All the details he's giving you are based on his calculations. If that changes because of a field condition, you have to go back to the engineer, okay? Don't assume anything as far as size. Don't assume anything as far as detail. Follow the details that are given to you on the pages preceding the civil plan. Everybody got that? Dan?
Joe, can you explain maybe next week what invert means when you get it?
Yeah, we'll get to that. This is not something you are going to get in 1 week. Okay, what I gave you today was a general overview of this. We could do a whole week on just drainage. We can do a whole week on just septic. But you needed an overview before we can get to the next item. So take these and get comfortable with them. Be comfortable with grade. Make sure you understand what it means. If you have a question, Dan, myself, anybody here can go through and give you help with this, okay? The intention here is for you guys to understand what you're doing while you're doing it. When you're on a job, look at the drawings that are there. The guys doing the grading, the surveyor will come out and check points. When we do the driveway, the surveyor will come out and give you points around the driveway to make sure your curve is right. He'll actually mark on the stake he puts in what the elevation is there that's supposed to be finished. So we're getting it rough, and then we're going to fine tune it. Okay? Any questions?
Thanks, Joe.
Go to meeting.